Right. Hello, calculus, back again. We are still here on the same day talking about our day 4, and we're going to talk about now the domain of combining these functions. Hopefully you had a fun game. No sore losers on that, right? We had fun, we passed that along. Raise your hand if you got the last one right. Okay, that's the tough one, hopefully. We're getting there. But here's what we're going to do. We're going to go ahead and take two functions. Here's f of x is 1 over x. And h of x is 1 over x minus 4, and let's just look at the domain. You know, what can work for this? So when I ask you to take f plus, oh, here I was doing all this early. This isn't function g. We don't have function g anymore. It's function h, okay? So we're going to take f plus h of x. And what's its domain? We're going to think, well, what do I need to do here? You know, what is the domain of this already? Well, for 1 over x, remember we can't divide by 0 and we can't take an even root of a negative. Those are the two things we're doing so far. So x does not equal 0. It's the rest of the reals. I don't need to write x as all reals, because if you tell me x is all reals and x can't equal 0, I get confused. One of them says it's everything, one of them says it's not everything. So I just, hey, just tell me x does not equal 0. Okay? And then what about the domain over here? Well, I can't have 0 on the bottom, so x does not equal 4. So in order for me to get an answer to adding these two things, I think I need to be able to complete both of them. So this one, this domain, is x does not equal 0, comma 4. Those are the two things that can't be. It's got to work in both. If it works in both, I can get an answer. If it doesn't work in one, it doesn't matter what it is in the other one, I can't get an answer. Now, what happens if I subtract these two things? Well, it's the same thing. You know, we just take the smaller of the two sets, and we take and say, oh, what works here, what works there, it's got to work in both. So it has to, we take the intersection of that and say, oh, it's got to work in both. There we go. What if I'm going to multiply? Okay. Well, if I multiply the two, f times h of x, then, wait a second. Same thing. I got to have an answer for both in order to multiply. Okay, and what about the last one here? F divided by h of x. So if I take f and I divide it by h of x, first of all, I have to get an answer for f. Then I have to get an answer for h. Okay? And if I get an answer for both, we're good. Okay? So I know this. X cannot equal 0 and 4. But ask yourself, can h of x be 0? Is there a number that makes h of x 0? And in this case, there's not. Okay? There's no answer that makes h of x 0. So let's go back to our buddy f of x. G of x. Let's just call it x minus 2. And so, when domain of that one, by the way, x equals all reals. Okay, so we're on the same track there. And if I say f divided by, and we're going to take f and we're going to divide it by g of x. Okay, well, what's the domain? Here's the deal. It has to work in both. So everything except for 0 will work in f, so x cannot equal 0. Everything works over there, so it should be all the rest of the reals. Except for there's one problem. Because this was division, I'll be dividing by g of x, and there is a number here that I can input into x that'll make the result be 0. In fact, if I put in 2, the answer is 0, and then I'd be dividing by 0 here. If I put in 2, think of it, f over g of 2 would give me a half divided by 0. And that won't work. So, there is another number that it cannot be. And in this case, it cannot be 2. X cannot be 0 and cannot be 2. Likewise, if I switch this around and I say g over f of x, well, now all reals work for the top, but for the bottom, the only one that doesn't work is 0, and putting in 0 gives me 0. So in this case, when I say its domain, this would be x cannot equal 0. That'd be the only one for that. So when I do division, because division order is important, these answers will change. Okay? Those answers will change. All right. So hopefully that's clear that, when I'm doing addition, subtraction, multiplication, and division, I just have to look at the two sets, the two domains kind of separately and say, well, it's got to work for both. And as long as it works for both, that's in my domain. Except for division, it can't.